Hello students, good morning to all. I am Rao Sharma from LPM Public School, Gorakhpur. Today I am going to take lecture of 12th class. As you know, this is a physics lecture. Unit electrostatics is going on, and the chapter electric charge and electric field. Today we have to discuss about the torque acting on a dipole. The torque acting on a dipole in a uniform electric field. So, as you know, to represent uniform electric field, the lines, electric field lines, travel parallel to each other. It means if electric field lines are travel parallel to each other, it means this is the uniform electric field. So let a dipole AB of length 12, a dipole of length 12, this is dipole AB, length of the dipole is 12, length of the dipole is 12, the positive charge placed at point B and negative charge placed at point A. So in this case, this is E, electric field intensity, then a force acting at point B, and the direction of force is F. That this force is F1 due to electric field on +2 charge, and the force F2. This is the opposite direction to the electric field. So now the net electric force, in an uniform electric field. Net electric force on a dipole in uniform electric field. So the F net equal to F1 plus F2, and the F1 is due to plus Q, so it is QE, and F2 is minus Q, so it is minus QE. It means the net force will be 0, or you can make an F1 in vector the net force. If you want to make vector quantity, F1 minus F2, and this is QE and QE, so this is equal to 0. So as you want to make in vector form, so it is QE minus Q naught, F1 acting towards east and F2 towards west. So the resultant F1 minus F2. So it will be 0. And if you want to put the magnitude value in F1 QE, and this is F2 is minus QE, so FE and QE minus QE, this is equal to 0. So it means the net force acting on a dipole will be 0 at uniform electric field. And this dipole experience a torque. This dipole experience a torque because as you can see, the F1 and F2 F1 and F2 acting opposite to each other, but the line of action of force is not parallel to each other. It means the line of action is different. You can see. So it means this force not cancel to each other. Do not cancel to each other, and this force make a torque, produce a torque. This couple of force produce a torque, and due to this torque dipole, the force will act, the torque will act to such that the dipole come into parallel to the direction of electric field. This torque wanted to rotate this dipole. This torque wanted to rotate this dipole and assign this dipole in the direction of electric field. So to find the value of torque, you can write language, let F1 acting on charge plus Q at point B, and F2 acting on charge minus Q at point A, and this pair of force produce torque, and the value of torque equal to magnitude of either charge, and perpendicular displacement. Let the dipole makes angle theta with the direction of dipole. When the line produced from point A and a normal is drawn from point B, then these two lines intersect perpendicularly. This is 90-degree angle. So this is, let this point C, they intersect at point C, then line BC perpendicular on AC. So torque equal to magnitude of either charge into perpendicular distance. Magnitude of either charge into perpendicular displacement. So now, what is the value of torque? So torque equal to the charge plus Q and minus Q. So it means F, that is force. You have to take the magnitude value of force into perpendicular distance BC. This is the perpendicular distance. So torque equal to minus Q minus QE, and the perpendicular distance, you can find this perpendicular distance sin theta is equal to perpendicular upon hypotenuse, it means AB. So BC equal to AB sin theta. So AB equal to 2L sin theta. So value of BC is equal to 2L sin theta. So this BC, so torque equal to QE into BC is equal to 2L sin theta. This is the value of torque. So torque equal to E 2L sin theta. 2L sin theta. And as we know, T equal to 2L. T is electric dipole moment. So torque equal to EP sin theta. EP sin theta. And due to this sin theta, as you know, torque is a vector quantity. So the cross multiply. Torque equal to P cross E. This is the vector form of torque acting on this dipole. So now we can discuss about the maximum, minimum and zero value of torque. So this is torque equal to P cross E. So this is very important. Note this, and you can take this screenshot. I am going to erase. Now, if we have to discuss about the maximum value of torque, maximum torque when theta is equal to, or you can take different condition. Case first, when theta is equal to 0 degree. This is first case. In this case, the angle between electric field and dipole will be 0. It means theta is equal to 0. So tau equal to PE sin theta. So tau equal to PE sin 0, and the value of sin 0 is 0. So it means tau equal to 0. This is the minimum torque. And in this condition there is no torque. This is known as stable condition. This is very important point. Stable condition, when the dipole parallel to the direction of electric field. This is known as stable condition. Stable form. Stable dipole. Okay. So now case second. So case second, when theta is equal to 90 degree. When theta is equal to 90 degree. So in this case, tau equal to PE sin 90. So PE, as you know, the value of sin 90 is 1. And it is equal to 1. Tau equal to PE maximum. This is the maximum torque when your dipole is placed like this, it means plus q minus q, and distance is 12. So in this case, the torque will be maximum. The torque will be maximum, and this is unstable dipole. This is unstable dipole. So in board question will ask what is stable and unstable condition of dipole. When dipole placed parallel to the direction of electric field, this is stable dipole. When your dipole is placed perpendicular to the direction of electric field, this is unstable dipole, unstable condition. Okay. So now you can find the other position if theta is equal to 30 degree. When case third, theta is equal to 30 degree. So tau is equal to PE sin theta. So tau is equal to PE sin 30. And the value of sin 30 is PE 1/2. The value of sin 30 is 1/2. Now equal to PE 1/2. So in this case, the torque will be half when your dipole is placed at angle 30 degree. So I hope you understood this various case about the dipole. Now, if we have to discuss if this dipole is placed in non-uniform dipole, placed in non-uniform electric field. If this dipole is placed in non-uniform electric field. So when the dipole is placed non-uniform electric field, in this case, if the direction of electric field E and the dipole this is the direction of non-uniform electric field, and this non-uniform electric field is not necessary two electric field lines are parallel to each other. In uniform electric field, this is uniform electric field, dipole placed like this plus q and minus q. If the direction of non-uniform electric field towards positive charge, left to right, so in this case plus q experience more force. This plus q charge experience more force, and minus q less force. Less force acting on minus q charge and more force acting on plus q charge. And if this is dipole plus q minus q, this is minus q, and the direction of electric field, this is the direction of non-uniform electric field. So in this case, plus q experience more force and minus q less force. If the direction of electric field is opposite, so in this case the minus q experience more force and plus q experience less force. So this is non-uniform case, and in uniform force will be equal but in opposite direction, but in non-uniform the force will be unequal. It is depend upon the direction of electric field. So I hope you understand the numerical based on this topic. I will explain in my next video. Thank you very much.